Welcome to Nexa Spaces, your gateway to the groundbreaking technologies shaping our world and beyond. Today, we're embarking on an in-depth journey into plant health monitoring system, a revolutionary fusion of science and innovation that's transforming agriculture into a predictive, interconnected masterpiece. From lush greenhouses to remote fields, and even space-based farms, these systems are ensuring plants not only survive, but thrive in the face of modern challenges. So, grab a seat, because we're about to explore every detail of how they work, step by step, sensor by sensor, and innovation by innovation. Let's start at the foundation: sensor-based data collection. Picture this: tiny, high-tech detectives embedded right where the action happens. Soil moisture sensors dive into the earth, measuring water content to prevent overwatering or devastating drought. Temperature and humidity sensors, like the DHT-11, keep a constant eye on the air, ensuring the perfect balance for photosynthesis and transpiration. Light sensors, such as LDRs, track sunlight intensity critical whether plants bask under natural rays or artificial grow lights. But it doesn't stop there. AIoT sensors monitor soil acidity, while electrical conductivity sensors assess nutrient levels and salinity, key factors for crops like tomatoes. And for the cutting edge, infrared sensors scan plant surfaces for stress, while nanosensors and phytosensors, using nanotechnology or synthetic biology, detect internal signals like hydrogen peroxide waves or phytohormones, alerting us to hidden threats in real time. These sensors are the eyes and ears of the system, collecting data with precision that's out of this world. Now, how does all this data reach us? Enter AIoT integration, the nervous system of modern farming. Using wireless modules like ESP8266 or Raspberry Pi, these sensors send their findings to a central server, cloud platform, or even your smartphone app in real time. Imagine a farmer in a remote Antarctic greenhouse, miles from civilization, still getting updates via satellite links using 6-low-BEW technology. This connectivity isn't just convenient, it's the backbone of a predictive ecosystem. Whether it's a high-tech urban farm or a space station garden, IoT ensures every plant is monitored, every condition optimized, bridging the gap between nature and technology. Once the data is collected, it's time for data processing and analysis, where the real magic happens. Microcontrollers like Arduino or Node NCU process the raw numbers on site, triggering immediate actions like watering or ventilation. But for deeper insights, advanced image processing takes center stage. Cameras and hyperspectral imagers capture detailed plant images, using techniques like k-means clustering or support vector machines to segment diseased areas or assess chlorophyll levels with pinpoint accuracy. And here's where it gets truly exciting: machine learning. By analyzing historical and real-time data, these algorithms can predict issues like nutrient deficiencies or pest infestations with up to 97% accuracy in some studies. Farmers get actionable insights, sometimes before a plant even shows a visible symptom, displayed on intuitive dashboards or mobile apps. It's like giving plants a voice. With all this intelligence, automated response systems step in to take action. Actuators and control units are the hands of the operation. Water pumps turn on when soil moisture dips. Solenoid valves adjust irrigation, and heaters or fans kick in to regulate temperature. These responses are driven by smart feedback loops, programmed to adapt in real time. For example, if a sensor detects high humidity, the system might activate dehumidifiers to protect the crop. This automation reduces human labor, minimizes resource waste, and keeps plants in their ideal growing zone, proof that technology can work hand in hand with nature. But the innovation doesn't end with automation. Let's explore non-destructive monitoring techniques, methods that keep plants intact while revealing their secrets. Hyperspectral imaging uses visible, near-infrared, and short-wave infrared wavelengths to detect changes in leaf reflectance, spotting water stress or disease long before the naked eye can. Volatile organic compound profiling analyzes the scents plants emit, flagging pathogen attacks or physiological stress without a single cut. And wearable sensors, flexible, biocompatible wonders like adaptive winding strain sensors, wrap around stems to monitor growth or water status in real time, all without harming the plant. These techniques are revolutionizing precision agriculture and even supporting space missions, where non-invasive monitoring is a must. So, what does this mean for the real world? The applications are transformative. Early stress detection allows farmers to catch drought, salinity, or disease at the first sign, saving crops and resources. Resource optimization ensures water, fertilizers, and pesticides are used precisely, reducing environmental impact and costs. And yield improvement, well, that's the ultimate goal. Take greenhouses growing tomatoes. Sensors adjust irrigation based on xylem sap movement or salinity levels, boosting productivity. Or consider the EEDIN ISS project in Antarctica, where high-definition cameras and spectral imagers provide remote health assessments for space-bound crops. These systems are not just for Earth, they're paving the way for sustainable food production in the cosmos. But let's dig deeper into the technology. For instance, nanosensors can be engineered to detect specific plant signals, like calcium waves triggered by touch or injury, offering a window into a plant's nervous system. In controlled environments, 5G integration is enhancing communication speeds, making automation even more responsive. And with machine learning models improving daily, we're seeing predictive analytics that can forecast yield based on weather patterns or soil conditions months in advance. The potential is limitless. Imagine urban vertical farms feeding cities, or Martian greenhouses sustaining future colonies. This is agriculture reimagined. At Nexuspaces, we're thrilled to showcase the technologies building a better, greener tomorrow. Plant health monitoring systems are at the heart of predictive, interconnected agricultural revolution, one that tackles climate change, population growth, and even space exploration. We've covered the sensors, the IoT, the analysis, the automation, and the real-world impact. But there's so much more to explore. If you're as excited as we are, hit that like button, subscribe to Nexuspaces, and ring the bell for more deep dives into the future. Share your thoughts in the comments. How do you see this technology changing farming? Until next time, keep exploring the infinite possibilities with Nexuspaces.